My name's Harriet. I hack your AI, so the bad guys can't.
So we know that AI systems are vulnerable, but why is that exactly? That's what we're going to discuss today. Welcome to my channel, I'm Harriet. I missed the boat in computer hacking, so now I hack AI instead. And I'm here to help you understand how you can secure your AI systems from attackers. So I guess in talking about why artificial intelligence systems are vulnerable, I kind of need to talk about why machine learning systems are vulnerable. And if you're not sure the difference, I recommend you check out these other videos. But basically, what I'm going to do here is I'm going to actually build a machine learning model for you. So this is a convolutional neural network. And if you don't know what that is, again, check out this video. But this is basically a model that is very good at computer vision tasks. So looking at a picture and predicting what it is, making a classification of what it is. In this case, this is a model that is based on the MNIST dataset, which is a dataset of handwritten numbers. And so the model that I'm going to build is going to look at one of these, an example of a new handwritten number, and predict what it is. So because this takes a few minutes to train, I'm going to start now and then talk about it. So let's go down here. Okay, I'm doing this. Now what you notice here is that I'm actually designating all the layers that are going to be included in this model. So if you know anything about machine learning models, you know that deep machine learning models, specifically deep neural networks, are really important because that is what has made our models a lot more accurate lately. The ability to have many layers, the ability to create architectures that are many layers deep. They learn different things at each layer. But you might not know that as the data scientist, I actually have to specify quite a lot of information about not just the model itself, but all of these layers. So you'll notice all of the things I'm specifying, like what kind of mathematical optimization function I'm using down here, for example, specifically the input shape or the output shape or what kind of layer it is. And while I'm not necessarily building the layers from scratch, I'm even importing them from other packages. There's quite a lot of thought that the data scientist has to put into how to build the model appropriately. Okay, so I'm going to run down here and now I'm going to start training the model. And this is going to take 4 to 5 minutes. So that's why I started this early. So when we're thinking about why machine learning systems are vulnerable, it can help to think back to cyber and information security. And if you want to know more about that, watch this video here. So in cyber and information security, they basically use the analogy of a house to describe a system and how vulnerable it might be, and to put it in terms of risk. So if you have a house, you don't want your nosy neighbors to come in and have a look around. You don't want criminals to come in and steal your television. So you'll do things like have windows with locks on it and doors with locks. Maybe you'll have a camera system set up. Maybe you'll have a gate with a code. You'll have all these different defenses you put in place to secure your house. When you think of a computer system, you have the same. You have different defenses based on the different entry points. So if you have a door, you would have a specific combination of security mitigations for that door, just as you would have different considerations for your window or a gate or the chimney, I don't know. However, you always have to balance that out with the fact that you have to get into your house. So you could, in theory, pick up your house and move it to the moon. That would prevent any criminal from getting in. However, it would also be very difficult for you to get in. I don't have an easy way of getting to the moon. Maybe if I make it far enough in my tech career, I will, but for now I do not. So just like thinking about this in a cyber system, the way you think about this is as the system as an attack surface. So there are lots of different bugs that lead to potential vulnerabilities and therefore possibly exploits. Now, when people talk about artificial intelligence, they tend to talk about it as this very ephemeral thing, as if it doesn't have its own internal system, like it's a human, where you don't totally understand what's inside it, but you can point it at something and affect an outcome. But that's not how most artificial intelligence systems work. Yes, there is this idea of them being black box, they're not necessarily explainable or interpretable, but you do tend to know what architecture you built in the first place to get to the desired outcome and what training process the data scientist or the practitioner has put that model through. And so all of the different ways that a data scientist can build this model and all the different ways that a model is implemented, in a production environment, and depending on the use case, the kinds kinds of inputs that it's receiving from the public or other systems or other developers. And then the outputs, these are all things that are analogous to that house example in cyber. These are all potential bugs, potential vulnerabilities, potential exploits, and they're all different for every kind of machine learning model and every kind of artificial intelligence system that it's used in. And this means that every system that incorporates artificial intelligence and machine learning models is vulnerable in some way. Maybe it's not obvious. Maybe it's not easy for people to get into it, but it is still vulnerable. And so as organizations adopt more and more artificial intelligence and machine learning systems, and attackers and adversaries are more aware of how they can deceive, disrupt, and disclose information from these systems, it becomes a real problem. Many of these productionized systems will remain vulnerable unless more people are aware of how we can defend against these kinds of attacks now. And that's what I hope I'm doing with this channel. So now let's head back to the model, and we can see that I've trained it. Fantastic. And now if I feed it a new piece of information, we can see that it predicts it correctly, which is ideal. But I just wanted to show you first of all, how long it still takes to train a fairly small model. This is pretty tiny in relative terms, compared to something like GPT-4, but also how much of the data scientist's input is required. How a machine learning system, it's not that black box, it's hard to interpret what each of the neurons mean, absolutely. But when it comes to actually looking at all of the layers and how they might be vulnerable and potentially exploited, there is a lot that we can see and understand about the model now, and we should be starting to build this information into the way that we ensure that we're building systems from the ground up to be secure from the start and more robust in the training and design process. Now, I'm really interested to know how much you know about machine learning. Is this surprising to you? Add a comment down below. I'm really interested to find out. And if you want to support me and my channel, please give this video a like and subscribe to the channel so you don't miss out on another episode. And that's it for now. I'll see you in the next episode.